Welcome to this talk called Secure Coding Back to Basics. I had the idea for this talk a few years ago, and I've kind of been wanting to do it for some time. And the idea of the talk was to do a talk that was kind of beginner-friendly, because we have a lot of people kind of moving into security. And in a lot of other talks, we talk about like advanced exploits and stuff like that. But what about like the basics? But I also wanted to create a talk that was valuable also for experienced programmers. So I'm going to try to show you some concepts that we can use in code that you might or may not find valuable. I think they're really useful because I've used them in projects. We'll see how that goes. I will show some code in many of the slides. The code will be in various languages. I know a lot of people going to NDC is like C# programmers and stuff like that, but this will be like Java and Kotlin and even TypeScript. I think it will be very much translatable over to, for instance, C# because I know people who have done it. I'm Erlend. I work as a security researcher at Crosspoint Labs, which is actually in this building. Recently started there. I write casual bug bounty hunter because there's longer and longer breaks between each time I do bug bounty hunting these days. And I also build and maintain some open source security tools, and I'm an OWASP chapter lead here in Norway. Actually, to say OWASP Oslo because we now have a Kristiansand chapter as well, which is great. First thing first, complexity is the enemy of security. This has been said many, many times, and it's really true. Like the more complex our code becomes, the harder it is to secure. And things tend to grow over time, right? But like we keep adding stuff and making things more complex. They start out at something simple. We have an idea for a program that we want to build, or a website or whatever, and we build it, and then we get new features, and we kind of add stuff. And especially if we're pressed on time, we never have time to kind of rewrite stuff and simplify stuff. So things tend to get more and more complex as we go. And this is, of course, a problem. The more complex stuff is, as I said, the harder it is to secure, and the harder it is to get things right. And when we don't get things right, we have bugs. And vulnerabilities, they are also just bugs. There's nothing special about a security bug as opposed to another bug. They're just bugs. So when we write something that happens to be insecure, our code can do something that it wasn't supposed to do under some certain circumstances. And various security companies have suggested that 50% of security vulnerabilities are actually logical security bugs. And this part is quite interesting because a generic scanner can only find generic bugs. It can't find the logical security bugs because the logical security bugs are based on the rules of the domain we're in. So if we're writing code for a certain business function and that function has certain rules, that there's no way a scanner can know about those rules. So we will have problems that are related to things that can be done in weird order, things that can be broken, like authorization bugs and all kinds of stuff that can go wrong. I'm going to show you bug types in order of personal preference. Some of you might not agree with this, but I really like compile time errors. Those are the best because I get them in my face immediately. So I know there's something to fix, right? They're there. Hey, you did something wrong. You're stupid. Fix it. Okay, cool. I'll fix it. The next type of bugs that I'd rather have them as compile time bugs, but okay, if they're caught by automated tests, that's cool. I'll find them before I go into production. Great. Or maybe I have some colleagues that kind of looking at my code and say, hey, what are you doing here? Oh, okay, that's fine as well. I'd rather have them found by the automated tests, but okay, as long as someone finds them, that's fine. Even manual tests, better than having things into production. Then, of course, a standard runtime bug, something that was supposed to work in a certain way, didn't, but wasn't necessarily vulnerability, which is the next thing. I don't want vulnerabilities in production. And I especially don't want exploited vulnerabilities in production. And I have to add this at the end, like those really annoying bugs that only occur under certain circumstances, and you can't really find out what they are, and you spend days and weeks trying to figure out exactly what's going on and why this stupid message is ending up in the log every Thursday at 12 or something. But the point of this is I want things to move upwards. Like, the more things that I can have as compile time errors, the happier I will be. And I've been in the security space for quite a long time. I wrote this blog post in 2006, and I was thinking about, like, okay, what's going on? Why do we have all these security issues? And people kept saying, you have to validate your inputs. And of course, yeah, I should validate my inputs. But then at some point I realized, well, validating our inputs is not going to stop SQL injection or cross-site scripting. Because it's kind of a different problem. And it's kind of paradoxical that I'm now going to talk a lot about input validation for the next minutes. But I still think input validation has a place and is super important, but it's not necessarily what's going to stop SQL injection and cross-site scripting. But the reason why I'm bringing this up is I wrote this blog post, and then later I wrote a series of blog posts that caught the attention of some Swedes. And these Swedes work for a company called Omega Point, and they are really smart. And so they were working on an idea that they were calling domain-driven security. And they read my blog post and said, hey, this guy's thinking about some of the same stuff as us. We should talk to him. And so a guy called Dan Jonsson contacted me and said, hey, I saw your blog post. This is interesting because we're working on this idea over here. And I really liked their idea. Their ideas were much better than mine. And they actually also, they took some inspiration from domain-driven design, hence the name domain-driven security. And then they kind of built stuff around it and used the concepts from domain-driven design. And it also ended up in a book that they wrote called Secure by Design, which I highly recommend. I mentioned domain-driven design. For those of you who are not fluent in domain-driven design, I'm going to just mention three terms that are often used in domain-driven design. We have a ubiquitous language, which is like a language that we use within a company or in a certain part of a company where we have specific words with a specific meaning that may not mean anything to someone or may mean something completely different to someone outside. We have a bounded context. This is kind of a closed context where this thing is valid, and we can have many bounded contexts. And then we have what we call an anti-corruption layer, which is when we move things in and out of the bounded context, we want to make sure that we don't break stuff and that we interpret things in the right order, kind of like input validation. To show you an example, if we have a quantity in a web shop, for the website itself or the web shop itself, if we're going to buy something, it needs to be larger than 0 because we can't buy 0 computers. We have to buy at least one computer if we want to buy something, but probably we don't want something or someone ordering like a huge amount of stuff either. So we have some rules around what is a quantity when we want to order something. So, but however, in the returns department, a quantity might be negative because we're getting something back. Like there's someone returning something, so we now get in a computer that someone didn't want, so they're returning it to us. So now a quantity can suddenly be negative. And so we can see we have two bounded contexts where the same terminology or the same term means different things. And this is often a cause of security problems because we think we're talking about the same thing, but we're not. And maybe it's possible on the website to order -2 books, and then we have a problem. When I was talking to Dan Jonsson and the others about this, Dan Jonsson also held a talk where he talked about like what happens with data, how can data be represented, and I created this slide where we have some data in a database, and then that data can be represented in many different ways in our system. So this is a very simple system where we have a database, we have a server. We have some JSON going back and forth. We have some query language that we can query the database. We're transferring it over to some JavaScripts running on the front end, which then uses some templating, and it's rendered into HTML. So the same entity sitting in a database can be an object on the server. It can be an object in JavaScript or just a struct in JavaScript. And it can be represented in many different ways in HTML. So for instance, if it's a user, it could be a row in a database, but it could be the icon up at the top that shows that you are like your avatar. It could be the form where you can edit your profile. Those are all representation of the same entity. And the point here is, so many of the problems that we have related to security, they happen when we move from one representation to another. So when we go from server-side into a query language, that's where SQL injection occurs. When we go from JavaScript into HTML, that's where XSS occurs. And when things are coming in from the client side into the server side, that's where all kinds of authorization errors and deserialization errors and all that kind of stuff occurs. So this going back and forth between different representations, that's a big part of the problem. Hence, we need to talk about input validation. But I don't think that input validation necessarily is only a security mechanism. I actually think it's more of a thing that we should think about as a data quality thing. Like, we want to make sure that this piece of data is valid. Like, does it make sense for this system to have this piece of data? Can a username be 1,000 characters? Probably not, because we have some ideas of the lengths of things and how things are supposed to be structured. So the fact that it stops or limits many types of attacks, that's actually kind of a side effect. Though that side effect is important. So when we talk about input validation, there are many ways of doing input validation. So we can think about format. So the syntax of the input. Does this look like a date, or is it just garbage? But if it's just a date, well, a date can be any date. It could be 1,000 years into the future, or it could be year 0. So we probably want some semantics. So if this is a birth date, our users are probably not born in 1556, and they're probably not born in 2048, because that doesn't make any sense. They probably weren't even born in 2022, because babies rarely use the internet. So we need some kind of validation. Sometimes we also want to check the data with other data that we have. So we might want to look up stuff in a database. The words I'm using here, syntax, semantics, domain, people use different terms for this. This can be confusing, but just remember that some things are just syntax. Some things are the values somehow valid? Do they seem valid in this context? And then sometimes we can't just do simple validation. We have to go look them up somewhere. That's the important part. So we talked about a birth date, so we could start just validating a syntax with the regex. Okay, so we have a year, we have a month, and we have a day. But as mentioned, we probably want to check that it's kind of between some sensible limits that we have, if we want to check that this value looks valid.
The month is not like 99.
Sorry?
And the month is not like 99.
Yeah, the month could be 99 up here, true. So that's also a problem. So it's a bit simplistic, the regex at the top. But we want to start somewhere. Next up, a product ID. Maybe the product ID is just a number, but we also want to check that that product actually exists before we allow it into an order, for instance. So we can't order a product that we don't have. But then we move into the harder things to validate, like a comment. So okay, so we could allow letters and numbers and spaces and stuff like that. But then suddenly, if this was Stack Overflow and you wanted people to be able to discuss programming, then you suddenly have to start allowing characters that can be used for attacks. For instance, a SQL injection or a cross-site scripting. Another problem is encoding. Encoding, things can be encoded in so many different ways. So in JavaScript, for instance, the string ABC has a length of 3. But this string, which also looks like it has 3 characters, has a length of 4. Because why not? The center character is a multi-byte character, so it consists of 2 surrogate pairs, and so JavaScript thinks this has a length of 4. We can also have weird stuff going on like this. So we have an A with an accent equals an A with an accent, and JavaScript says no. Okay. Why is that? Well, because one of them is the letter an accent and an A, so it's a combining character, and the other one is the actual letter A with an accent. So we can have an A with many accents. And then we have emojis. It looks like one character has length 11. Okay. But this tells us something, like it can be hard in certain languages to know the length of something if we want to impose limits. So Elm, for instance, they had the exact same issue because they kind of compiled stuff into JavaScript and they inherited all the weird length stuff that you see here. So we have to normalize input somehow. And we can do that by just deciding on a form. If we have the A with the accent, we could decide we always want to split these two things out. So we want to have the letter with an accent and then the A. Or we could say, well, if it's an A with an accent, we always use the letter A. So same thing for XML. Like an empty tag could be an opening and a closing tag just next to each other, or it could be like a self-closing tag. But we have to decide if we want to do validation. And then emails and URLs and host names. Well, you can have international letters in host names, for instance, but you have to decide, do you want to look at this as Punycode, or do you actually want to allow those characters in there? And you have to decide on this before you start doing the syntax validation and stuff like that. So we have to normalize the input. Another principle here is don't try to clean invalid inputs. So if you know something is bad, don't try to fix it by removing stuff. Just say, I don't want this as an application. Just say, this is invalid data, I don't want it. Don't try to, okay, we're going to fix stuff, I'm just going to remove some stuff. Because this is a very simple example. Like, okay, we're going to remove all the script tags. So we remove it once, and then we have a new script tag because like things are concatenated, and then you have a script all over again. So this is just a really dumb and simple example, but you can imagine stuff like this happening. If you try to fix the input, clean the input, then this might happen. So there are good cleaners that can do this for HTML, like DOM Purify. So if you want to do it, or actually need to clean something because you can't just reject everything, then at least use something that has been very well tested. But try to avoid it if you can. Just reject the input and say, I don't want this. So we have a set of steps. We normalize the input. We check the length first. And we check the length first before we go into regexes or stuff like that, because if we have quite a long string that doesn't exactly match, we might end up with our redos if our regular expression was poorly created. And other similar stuff. So we check the length before we go into the next things. So we check the format, we check the semantics, and then we use the value that we validated. This is also something I've seen so many times where people do normalization and do all kinds of checks, and then they end up using the value they started out with, which was not the one that went through normalization, etc. And last but not least, we check the domain if that's necessary, like so we can go and look up the ID in a database or whatever it is. So now I just talked about the input validation. What is this domain-driven security thing? This is a rather funny example, or depending on who you are. This was Apple. They were going to show you your password hint, but they accidentally showed you your password instead. So you had two fields, the hint and the password, and they were accidentally flipped in the code, so you showed the wrong thing. And this can happen because we tend to pick stupid types for stuff, basically. So this is Einar Høst, who works at NRK. And he says, did I mention I hate string? I hate string. People who have the decency to refrain from using object will still gladly use string with assumptions all over the place. We tend to use strings and primitive types a lot. And we don't necessarily mean string, because a string can be 0 bytes. It can be 2 gigabytes. Is that the string? Is that the string we want? I don't know. I found another blog post called Something Isn't Something Else. And I really like this picture. So we have this idea of something, the main concept. And then we kind of try to transfer that concept into code, and it doesn't really match because we're taking a lot of shortcuts. And it mentions primitive obsession down here. So we tend to like just pick some primitive, some strings and stuff, and just, okay, that works. But then we end up with something that's called stringly typed code. We don't really use the type system, we just use strings. String, string, string. Public void registered, string email address, string password, string phone number. Are they all the same? Really? If we look at, like, if we could, like, imagine this as the total amount of strings that we could have. So we have email addresses, and we have phone numbers, and they don't overlap. But we said string, 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 right? This is odd. Why are we doing this? Because, well, it's easy. But what if we did something like this instead? Email address, password, phone number. We had some classes. We had some types. Then we wouldn't accidentally flip the password and phone number or something like that, because the compiler would yell at us. Hey, this is not a phone number. This is a password. Okay. We could even do something like this. We could package them together in a class and actually have a proper encapsulation of them, and not pass a lot of strings. Okay. So, but if we look at the center one, so we have something called an email address. We have something called a phone number. This is what is called in a domain primitive. So we take a value and we kind of wrap it in a class. And the point of this is that class can enforce rules. So we take an implicit concept, which was a string, and we now make it explicit. So we have an email address instead of a string email address. We now have a proper email address or a phone number. So we can create a class, and within that class, if in the constructor, we're going to check that the string that we give it is in fact a phone number, or we might throw an exception and say, hey, this is not a phone number, this is a password, or this is an email address. It's not going to say that, it's just going to say invalid phone number, but you get the idea. We can have the class itself enforce that you're not inputting invalid data. And the point of this is, whenever we have an object of type phone number, we know that it contains valid data. A phone number object will never contain an email address, because you can't create an object like that. So, and we could also have like a method, a static method, so you could check something if you didn't want to go right into throwing exceptions and stuff like that. So this is one way of doing it. And of course, when people see this, they often think, well, okay, so I'm just going to write all these domain primitives, and then they kind of start accessing the value up there because it's public final string value. Huh. Why is it public? Why is it a string? Why is it available? Well, it's available because in this case it's immutable. We don't want anyone to be able to modify this later, so we set it up as a constant, as final. And we actually want code later to be able to get the value, but if you ever need to do an operation that belongs to phone number, say I want the area code or I want the country code, then that also belongs in this class. So don't make like wrappers around data and then put logic that relates to that concept elsewhere. Also add stuff like that. Yeah. Yes, this is definitely a part of domain-driven design. So this is not specific, but the point of this is we should use this more as a part of getting better security. So this is a part of we call it value objects in domain-driven design, but enforcing invariants is something that people tend to forget, or they write too little of these validation rules. So we could go a bit further with the phone number class. So in this case, we could go to Kotlin, and we can write it in a bit of a different fashion. So again, we have a constant where we store the value, and we have an init, which is kind of the constructor, and we say that this value must satisfy some checks. And then we have the checks where we can kind of simplify stuff and reuse stuff across. So we have some checks to say the length must be between 8 and 20, and it must match a certain a regex. And the point of this is we have a list of functions that we can call, and then we can reuse them as in other functions. So we can create a create method that returns what we call an either. And an either is a union type, or you might see it as a union type. So an either is either a validation error or it's a phone number. And the point of this is we might not want to throw exceptions. we might want to be able to return validation messages so we can show them to the users without kind of catching stuff. And maybe we want to validate the larger objects and get all the validation errors. So now we can do that. We can try to instantiate this object, and we either get a validation error or we get a phone number back. And then we can act on that. And we can also have the function that we had earlier is valid. We just check that it returned a right. So an either is an object that has either a left or a right. It doesn't have it never has both a validation error and a phone number. It either has one of them or the other. So that's taking it one step further. Next, we can look at the password primitive. So the password primitive, we might want to ensure that no one ever makes the mistake of doing toString, because that might happen if we're doing like deserialization or just a log statement or something like that. We never want to print the value, and we don't want to have a public variable in this case, because we want to make sure that we only ask for the password for this class if we absolutely mean to. So in this case, we can create a asString function just to have it. We could even have a counter there. It says you can only access this value a certain number of times, and then it will throw an exception, for instance. So we make sure that we're not like accidentally stealing this data elsewhere. So that's also one way to avoid having stuff printed. Again, we're using these primitives to handle it, so we don't have to know when we're writing a log statement like, oh, okay, I need to make sure that I don't print this thing and this thing. It's handled by the class instead. So some more examples. Email, maybe we want to check if the email is unique because it's for user registration. So we want to check does this user already exist? That's not something we can enforce in the email object itself, so we have to go check somewhere. Phone number, you might want to check that it's a mobile phone number, and that's quite hard. And Google has a library called for this, that has all the rules for all kinds of countries, where what's a mobile number, what's like a landline, and what's all other types of phone numbers that you can have. But that's also something we might have to check if we're going to use this for two-factor SMS, which we probably shouldn't. But anyway, passwords. We can have rules that says it should not contain the email or the phone number of the user and should not contain the names of the users. And you can kind of see where this is going. It's hard for the password object itself to know what the user's names and email and phone numbers are. So we can't necessarily enforce these in the primitive itself. But that's why we have the entities. So I mentioned the registration entity earlier. So here's a user registration entity. So the primitives that we have up there, they enforce the stuff that they can do, but then the entity can wrap these things and enforce rules across them. So it can check that we don't have the phone number in the password, etc. We want to register this user. We're using this user registration instead of like separate fields because we want them to be valid altogether as a concept. Now, next up, we see this thing here. So we're going to store the exact credentials because those are going to be stored in a specific way. And in this case, we have a username that's an email address, and then we have a validated password. So how do we get a validated password? What does it even mean? Well, a validated password could mean that we kind of go and look it up and see that this is not one of the commonly breached passwords that are spread across the internet in all kinds of lists. And that's not something that the password primitive can know itself. So in this case, we need kind of a transformer where we can go from a candidate password and to a validate password, and we can ask a service, hey, can you validate this password? Can I use this password? And then it can do the things I mentioned. It can go and look in one of these commonly breached password lists and say, no, this is not a good password. Or you could say, yes, you can use this password, it's good. And we could have the other rules that we want there. So the password primitive itself, it could enforce like simple syntax. So the password should be of a certain length, for instance. But we do need these services to actually do some of the work regardless. So next up, APIs. We have, again, our simple application here, just even more simplified because we've kind of merged the stuff on the left into a client. And then we have some data in the database. And we're going to read that data. So the client asks, hey, can I get some data? And we read it out of the database. We create an object on the server side, and we send it over to the client. Works perfectly. Then, at some point, we decide to add this new field. Let's say this was a credit rating or something that was secret, a token, or 2FA secret for the Authenticator app. And we store this together with the user data, in this case. But because we followed, let's say we were using Ruby on Rails or some other framework, which kind of just, oh, you have a model in your database, you're just going to send it right out to the client. And when we add this new field, we might accidentally end up also sending the new field out to the clients, because we didn't do anything specific to hide that field in the API. Similarly, we could have a way to store data. And normally in the web UI, we only send 2 fields. The 2 fields are sent in, we read the data from the database, we overwrite the 2 fields in question, and then we store the data back in the database. That works perfectly. But what happens if the user were to specify the 3rd field and send it in? Well, depending on how we wrote the server-side code in this case, we might end up overwriting the data that we weren't supposed to overwrite. So suddenly we have some read-only data that the user could influence. This is called a mass assignment attack. And there have been many, many examples of this, the most famous one being Egor Homakov on GitHub. Egor Homakov, he opened a GitHub issue that was 1,001 years into the future, because he was able to overwrite the created timestamp of this issue. And the reason why he did this was he was trying to tell the Ruby on Rails community, hey, Ruby on Rails is doing something stupid here. Like, they're kind of exposing everything, and it doesn't do any filtering by default, so I can just write whatever back. And then GitHub was vulnerable to this. And he went as far, because no one listened to him, so he went as far as adding his own SSH key to the Ruby on Rails GitHub repo. And then he got the attention. He was kicked out of GitHub for a while, and then they kind of realized that he was only trying to do this to show that this is an actual problem. And by doing this, he influenced the design of the next version of Ruby on Rails, where things were handled a bit differently. You had to tell which properties that were allowed to be set from the outside. But I think that's still kind of taking a model that we have on the server side and exposing it directly to the client. I don't like it, because then if I want to change something in my internal model, now I suddenly expose that to the clients. So we should, of course, have what we called DTOs or contracts, or even we could call it an anti-corruption layer. We want to have a specific type of object that represents the contracts that we have with our clients. So data transfer objects, contracts, whatever, they have many names. So in this case, instead of exposing the model directly, we copy stuff out, just the fields that we want. So we leave the secret field just on the server, and we send it to the client. So the client will not see the new field, because it's not a part of the model that we use for the communication with the client. Similarly, with this malicious client that's sending this extra field down here, that extra field that doesn't exist in the DTO, in the contract. So it's just going to be either discarded, or we just reject the request altogether. But if we decide to just discard any field we don't know about, well, at least we'll just copy the 2 fields that we like and put them back in the database. Again, we take like a really simple thing. It's a few lines of code to create these contracts, but people tend to think it's too difficult. I have to maintain all this stuff. But I can assure you it kind of gets harder if you don't. So let's say this is the wire format that we have. We have an order. The order has an ID, which is a GUID or a UID. And we have some items, and each of the items also has an ID. And then we have some quantities. So we're going to create a DTO for it. So we have an order DTO, which has an ID and some items. And we have an order line DTO, which has a product ID and a quantity. And as you can see here, we're mostly using primitives, because this is the DTO. This is going to be JSON or XML or whatever in the format that the data is coming in as. So in this case, we're using strings. We're using ints, because that's the representation we have when we're going to JSON. But we're gonna, when the data comes in, we want to actually transform it into stuff where we validate stuff. And then we can actually put this in the DTOs themselves. So we can create a to-domain method, which will take this DTO data and try to create the proper objects for it. So in this case, it will create an order ID with the string, and so it becomes a proper order ID where it checks that it's actually a UUID. And then it takes all the items that was in the list and creates proper objects for them as well, where we have a quantity that enforces the limits of what is a quantity. Is it 1? Is it 500? And also a product ID. And these two can be different because we probably want to separate order IDs from product IDs. We don't want to accidentally add an order as a product line. And this is actually a lot easier to do than, at least in a typed language, because we can create like a wrapped function and then just use inheritance to get the two others. So it's like 2 lines of code to get them separate. But now we won't accidentally in our code use a product ID instead of an order ID or vice versa, which is really, really nice. It might seem like a very trivial thing, but actually when you're writing code, it's really nice because you get compile time errors every time you try to use the wrong thing. Maybe you have like something that's just an ID and you don't know where it's coming from. Now, at least it has a type. And we can also say that the order DTO is not only responsible for going from the wire format and into the domain, but it's also responsible for going in the other direction. So the order DTO, or the DTOs in total, they now have a responsibility. The responsibility is to know how to map from the wire format or the DTO format and into the proper format that we want internally. So it's all hidden here. And so our internal objects, the proper order, it doesn't have to know anything about JSON, or it doesn't have to have these weird annotations where JSON serializable or all kinds of stuff like that. It doesn't have to care about that. That's the job of the DTO. Then we can also, because we talked about immutability earlier, like we have all these things that are val, which is a constant. Maybe we also want, if you're going to add a new order line to an order, we want that to be immutable as well. So instead of just adding it to the list, the list could be a read-only list, and instead we create an add function that returns either a new order with the new item added, or a validation order, a validation error. And then we have some checks that checks that, well, you can't have more than a certain amount of items in total on this order, and that can be enforced by the order entity in this case. So now we're kind of we have this immutability, which is nice as well, because we don't accidentally change values across and then suddenly there's something new in the list and suddenly we have too many items. Now it's not possible to create an order that has too many items because it does the validation before it's created. So we now have also a way to decide on what's the responsibility of a controller, a function or an endpoint function. What's it supposed to do? Well, it's supposed to map the request to the domain objects and thereby validate them because it tries to create the proper objects. Then it calls the correct processing method, and then we map the results back to HTTP response in this case. So now we have, this is what every controller method should do. It should not do any logic. That belongs to the processing method. So it could be like a service class or whatever sits behind it. And then we're back to this thing. So now I talked a lot about input validation. How if you want to create an object, you have to check everything. It should enforce stuff. And if you have a valid instance of an object, then that's it's certainly valid because we've done all the checks. But it's not the solution for SQL injection. Why is that? We could ask this guy. I think he's Dutch. And he tried to register his name, and that's his name. It's a valid name. And then he got a SQL injection error, or a SQL error, when he tried to register. And there's something with clear text passwords and stuff in there as well, which is bad error message. But still, if we wanted to apply input validation, well, it's still his name. He should be allowed to have that name, right? So in this case, input validation fails us because, well, there's this attacking character that he has in his name, and it kind of slides directly into a lot like Bobby tables, right? So the problem with cross-site scripting and SQL injection is data does not stay data. So we have some data coming in. We're going to put it, as I mentioned in the beginning, we're going to put it into a query language, and then we kind of break stuff. So data does not stay data. This is a bug, right? Data should stay data. It should not suddenly become control. It's a bug. But this is the problem with injections. It's not that we necessarily allowed all kinds of weird characters, because as we saw with the Dutch guy, those letters should be valid. So there have been some attempts, and I did this in my early career when I started to code as well. Like I tried to encode stuff during input validation. So like I took okay, I have the string, it contains this single quote. I'm going to encode it now because now I'm getting it into my code, and I'm going to encode it immediately so it never hits a SQL injection endpoint. And PHP did this for a long time by default. So whenever there was a single quote coming in, it would add a slash in front of it, which was super annoying when you tried to show that in HTML, and there was always a slash in front of all the single quotes. So don't do it during input validation because you don't know what the format is. You don't know where this thing is going to end up. It might end up in a database today, but like next week, maybe you've swapped the database, or maybe you're going to send it out in a JSON request. So don't do it there. You should do it when you're moving to the other format. So we should use the languages, we should use the constructs, we should use the APIs that we have to do this. So for instance, with SQL injection, there is parameterized queries. They handle this for us, we don't have to care. Good, it's just that we still tend to not use them in a lot of places because SQL injection is obviously still a problem. Then we have cross-site scripting. Now we have frameworks like React and Angular and Svelte and all those kinds of things. Most of the time, they handle cross-site scripting for us. They tend to escape stuff for us, so we don't have to care, except if we're using like dangerously set inner HTML and friends of that. And then for other types, we might have to escape or encode. And now I have a confession to make. I failed to communicate once, or I failed many times, but I failed to communicate once. I was doing a source code review, and I found lots of SQL injections with code looking like this. So there's some string concatenation happening here. This is not nice. So I was kind of finishing up my report, and I sent it over and said, hey, it's not a good idea to do string concatenation when you're building SQL statements. You should really use prepared statements. And so what I expected to happen was something like this in this case. Like, so we have the question mark instead of the parameter, and then we say statement set string to this ID, and then we execute the query. But what I got back a few weeks later was this. So they just used prepare statement, was still doing the string concatenation, because I didn't say stop doing string concatenation. I only said stop doing prepared statements. And this is a fault of mine. I communicated badly, and I think we sometimes do this as security people as well. We kind of assume that everyone else knows you should do it in this way, and then we don't explain it well enough. But the question is, can we do something with the APIs? And I think Philippe Deruc, who was talking yesterday, he had some great examples of this. We can wrap stuff. We can wrap security libraries. We can wrap stuff in things that helps us convey the message and makes it easier for our fellow developers to do things right. So the example Philip showed was a React module called, or a React component called safe HTML, which was using dangerously set inner HTML, but was also using DOM Purify, so that you could display rich data without risking cross-site scripting. But I'll also show you another example. Trusted types. This was mentioned in the keynote by Jim yesterday. What is trusted types? In our browsers, when we're writing code, one of the problems that we have with client-side cross-site scripting is we sometimes assign tainted data, which is data coming from a user, which they are in control over, to inner HTML or outer HTML, or we do document write, or we do all kinds of other stuff, or we use this dangerously set inner HTML thing, as shown down here in React. So we're kind of assigning tainted data into the DOM, which causes cross-site scripting. So with trusted types, we kind of change the API. So the way we do it is we set a header which says enforce trusted types for script. And now if we try to assign a string to inner HTML, it says, well, you can't do that anymore because you've enforced trusted types. So we modified the API to say the only thing that you can assign to inner HTML is something called trusted HTML. So you have to create a trusted HTML first. Aha. How do I create a trusted HTML? Well, you create a trusted HTML by creating a policy. You use trusted types to create a policy. And there you have a create HTML method that takes the string data and then converts it somehow. And then we can assign it after, or use that policy afterwards to assign to inner HTML. We can actually skip the policy if we want to, because DOM Purify, the guys behind it, are very clever. So they created a sanitize function that returns a trusted type. So if we have trusted types enforced, we can just ask DOM Purify to say, hey, return a trusted type once you've cleaned this data. And then things work as perfect. Another thing we could do, and this is something Philip de Roock showed me some months ago, is we can use a default policy. So the default policy will trigger if you try to assign a string to inner HTML. So instead of just blindly assigning the string, it's going to call the default policy to clean it. So now we can use DOM Purify, and this would even work in libraries, right? So you have a library, and that library is somewhere doing a stupid inner HTML assignment. It would even catch that. So if we just enforce trusted type and only have like a specific policy that you have to remember to call, we might end up breaking some libraries. But in this case, we kind of even fix that. So I've talked about some code that was kind of Kotlin-ish, and it could also have been very similar in C# or in Java. But what about TypeScript? A lot of developers these days are using TypeScript. Well, like we use it in Lambdas, we use it on the client side, of course, in compiled to JavaScript way. But what can we do here? Like if we want to do the input validation bit, what can we do? So we now have classes. Oh, let's use classes. Okay. So we create a username class, and then we have a constructor that takes some value, and it's a read-only. So it's very much similar to what we saw earlier. And then we do some checks. And then we do the same thing for password, and we create two instances, one of username and one of password, and we try to call this register function. So this should work, right? Register username password, that's great. The problem is, this also works. So if we flip them, it's still going to work because TypeScript. Well, not because TypeScript, because of duck typing. So what TypeScript actually sees here is not username and password. It sees some type with a thing called value, that's a string, and some other type that's a value and contains a string. And so that's why we can flip them. So we could even do something like this and bypass the validation altogether, because yeah, these match what we have up there. Like two empty strings, that matches. Okay, crap. What can we do about this then? Well, one thing we could do, which I don't recommend, is we could add private fields to all the method. So in this case, I'm adding a private field. It's called _I. It could be called anything. And it contains the value of 1. And we've added it in both places. So why are they here? Well, in this case, TypeScript compiler will actually complain. It will say, hey, you have a password and you have a username, but they have different declarations of this private property. So I don't like this, and it's going to throw an exception. But this is a bit ugly, in my opinion. So again, we could, of course, go to the entities and create an entity where we have proper names for the fields, and then use that. So at least there's only one place we can go wrong, and that's in the constructor. So we accidentally give the two values in reverse to the constructor. I think that's probably a better option. But what about input validation of JSON data? I see lots of places where people are kind of just assuming that data coming from the server is valid according to what they expect in the client-side code, or vice versa in the server-side code. We just assume that the code that's coming in, it has some strings, it has some ints in the right places, and we just kind of do like an as to cast it. And it's not so nice. But I discovered this library called SOD, and props to whoever Colin is, because this is a great piece of code. So what we can do with SOD is we can create contracts. So in this case, I'm creating a registration parser, and in this case, I'm saying, okay, an email is a string, it has a minimum length of 10 and a maximum size of 60, and it's going to match a specific regex, and then I take the regex from the specs for what you allow in a browser for an input field of type email, and use that. So that's one way to go. For a password in this case, I'm just going to check that it's a string and it has a length between 8 and 256. So you could easily add lots of more validation rules here. This is just a simple example to show it. And you could also combine these. So you could take the email, like you can say an email is this set string stuff, and then you can reuse that across many different parsers. And the cool thing about this is we can also ask SOD to create a type for it. So in this case, it won't be a fantastic type with proper classes and all kinds of stuff. It will still be primitives. But at least now we have a way to do proper input validation and get out a type without having to use JSON schema, which is not in tune with the classes that we have or the objects that we expect, the types that we created. Now it's all coming from this thing, and it becomes a type. And the way we use it is we parse the JSON data with a parse function, and it will throw an error if it's invalid. It would also remove all fields that it doesn't recognize by default. You can add a fall through if you don't want that, or you could tell it to throw an error if there are extra fields that you don't want. But this is one way of using it. It also has a similar way of using it as the either. We can use safe parse. So with safe parse, it's going to return a union type. And the union type is either a success or it's an error. So in this case, I'm asking, is this a success? And no, it's not. Then I have parse result error, which I can use to, if I want to show an error message, or if I want to log an error message, or whatever. And then I can use parse result.data to get the actual data that's now been parsed and validated and all that stuff. So no, we can't get like necessarily the proper type stuff that we had in the strongly typed languages, because it's duck typed, but at least we can get a lot further using this approach than just casting things. So I really, really like and recommend this library. So I've done this talk once before, and I always get the same questions, and I'm going to preempt some of your questions. Domain primitives seem fine and all, but have you ever used this on a real project? Yes, I have. I worked on a project for 3 years, and the only pieces of code I didn't like was the ones where we didn't use this, because it was very, very nice to have. The problems is often that, where do we put this input validation logic if we don't have the primitives? Well, okay, so we're going to have like a list of regexes somewhere, or some validation function with some static functions that does stuff. And we kind of tend to spread things around, and the validation rules, they don't have a home. They kind of just, okay, they're in the validation class, which is super long because it's used for all kinds of validation. Where do we put it? Now we have a home for it. It belongs in the primitives. So that's a nice thing. Of course, it can be an issue as well if you want to use the same rules both on the client side and on the server side, and you want to kind of expose them. But there are ways around that. But yes, I have used this on a real project, and yes, I really like it. It must take a lot of time to create all those small classes. It's not free, but security isn't free. And if you're not using the classes, you still should do validation. So this discussion is more, do you want to do validation or not? And if you want to do validation, then this is, I think, a good way of doing it. If not, you're going to have to spread it around and find ways of doing it that may or may not work. Of course, you could use schemas. Of course, you could do it in other ways. But I like the fact that it belongs in a specific place. What about equals and hash codes in those classes you created? Well, you got me there. you have to implement equals and hash code as well, of course, because you have to check that the value is the same. So I deliberately skipped it because I didn't want to show really long classes to trick you all. No, but yes, you have to do that, because if you want to check if two usernames are the same, of course you have to override the equals method, so it actually checks that the value is a match. What if we need to change the validation rules? This is the most difficult question. What if you already have data in the database, and then you need to change the validation rules, and then you have data in the database that no longer matches the new rules that you create? Yeah, this is annoying. This is super annoying. This is also a problem you will have regardless of how you do it, but you will. The problem here is you'll trigger it when you read data from the database and you try to convert them into objects. It will fail there, and that's a bit odd. But at least you know that you have a problem. So if you want to change the rules, one way of doing it is to have a script that you run before you actually deploy the code. So you kind of run a script before you deploy a new version to check all the fields. Okay, I'm going to check all the email address and check that they match this new validator that we created, and see if there are some errors, and then you can fix those. So we had this problem. We had some phone numbers where people have been just writing garbage data, and we had to import some data from an old system. And so we had lots of bad data in the database, and we had this exact problem. And there are ways around it. And it's annoying there and then, but in the long run, having proper data is so much better. So I'm going to try to summarize the things that I think about this. You might disagree, but I think the first part, input validation and encoding or escaping stuff, both of them are needed. It's defense in depth. We need to validate data as it comes into the application, and we also need to encode or escape it as it's leaving the application. I think domain-driven security can help us here. I think it puts input validation in the right place. I think it can enforce better data quality because we have proper types going around. And it can stop and hamper many types of attack because of the input validation stuff. And we can get things that used to be runtime bugs to become compile time bugs because we're going to catch them because the types are wrong. And then we can have questions if there are any. So I'm going to try to summarize for the people on stream. So one of the points was if you're using just domain primitives, then you can't kind of reuse and you can't do validation across different primitives. And as I mentioned, we have the entities. So the entities can do cross-field validation. The other point was when we're creating all these classes, we're using more memory. So it might make sense to, instead of validating each field, to have to do the validation on the aggregate root or the entity, just on the entity, and then still have strings. And those are valid concerns if memory is an issue. In the systems that I have been working on, where we had lots of transactions going through, we didn't really see the memory issue as a big thing for us. But of course, that might be a valid concern for your code. So the question was here: is there like in my examples, I showed that we had the input validations rule into the objects, and is there a way to specify them kind of outside the code and have them either compiled into or stuff like that? There probably is. I think that having them there makes a lot of sense because they kind of belong to that object. I know where it is. I know where I have to fix it if it's there. But there are cases, as I mentioned, if you want to have the same input validation rules on the client and on the server, you might have to extract them so you can kind of use them in both places and have them available both to, let's say, Java or TypeScript and something like that. So this is not a perfect solution, but I just think it's a lot better than lots of other stuff I worked on and seen. So, yeah. And I think that's it. We're out of time. If you have any more questions, please feel free to come up and heckle me. That's fine. Thank you.